GCE O Level Mathematics, Lecture 4, Standard Form and Prefixes. Hello everyone, I'm Dennis. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out free lessons from me. The learning objectives of this video are: first, to read and interpret standard form. Second, to perform 4 operations of standard form. Next, to understand prefixes. And lastly, to solve word problems related to standard form and prefixes. Let's start the lecture with the introduction of standard form. What is standard form? Standard form, or also known as scientific notation, is used to express very big or very small numbers. Standard form is expressed in the form of k times 10 to the power n, where k must be greater or equals to 1 and less than 10, and n is an integer. Let's study the pattern below. 2.3 times 10, we know that it is equals to 23. So if 20 times 10, there's 1 0 here, which means we need to move the decimal point for 1 decimal place. And there's the answer, 23. Similarly, 2.3 times 100, we know that the answer is 230. Because 100, there are 2 zeros, so we move the decimal point for 2 decimal places, so that we'll get 230. We can also write the answer as 2.3 times 10 squared. How about 2.3 times 1000? The answer is 2300. Why? Because there are 3 zeros in 1000, which means we need to move the decimal points for 3 decimal places to the right, and we get 2300. We also can write 2300 as 2.3 times 10 to the power of 3. We can repeat the same process for a very big number like 2.3 times 1 million. So there are 6 zeros in 1 million, which means that the answer is 2,300,000, because we need to move the decimal point to the right for 6 decimal places. So this is 6 decimal places. We also can write 2,300,000 as 2.3 times 10 to the power 6. Next, how about small numbers? Let's look at this pattern. 2.3 times 0.1, it is equals to 0.23. So look at 0.1, it means that we divide 10. So which means that we need to move the decimal point at 2.3 to the left for 1 decimal place. Hence, we get 0.23. How about 2.3 times 0.01? We get 0.023. Why? Because when we multiply 0.01, it means that we need to divide the number by 100. So in other words, the decimal point at 2.3, we need to move 2 decimal places to the left. Hence, we get 0.023. We also can write 0.023 as 2.3 times 10 to the power of negative 2. Next, 2.3 times 0.001. When we multiply 0.001, we divide the number by 1000. So in 1000, there are 3 zeros. Then we need to move the decimal point for 3 decimal places to the left. And we get the answer as 0.0023. Here is 3 decimal places. And we can write 0.0023 equals 2.3 times 10 to the power of negative 3. We can repeat the same process for even smaller number like 2.3 times 0.000001. So when we multiply 0.000001, we divide the number by 1 million. So in 1 million, there are 6 zeros, which means we need to move the decimal point at 2.3 to the left for 6 decimal places. So 1, 2, 3, 4, 5, 6. Hence, our answer is 0.0000023. Or we can write it in standard form, which is 2.3 times 10 to the power of negative 6. Here's 6 decimal places. Now, let's look at this example. Express the following numbers in standard form. A. 56,500,000. B. 37,700,000,000. C. 0.0000021. D. 0.074. Here's the solution. For A, 56,500,000. Here is our decimal point, and we need to move the decimal point to the left. Then let's count. 1, 2, 3, 4, 5, 6, 7. So we want to make this number to be greater than 1 and less than 10. Hence, it is 5.65 times 10 to the power of 7. For B, the answer is 3.77 times 10 to the power of 10. Why? Because here's our decimal point, and we need to move the decimal point to the left so that the number will be between 1 to 10. And let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Therefore, it is 3.77 times 10 to the power of 10. For C, 0.0000021, we repeat the same process, and this time round, we need to move the decimal point to the right. So here's our decimal point. We move it to the right. So 1, 2, 3, 4, 5, 6. So we move the decimal point to the right for 6 times. Hence, the answer is 2.1 times 10 to the power of negative 6. For C, 0.074. So let's move the decimal point to the right again and count. 1, 2. So the answer is 7.4 times 10 to the power of negative 2. Remember, when you move the decimal point to the left, the power of 10 will be positive. And when you move the decimal point to the right, the power of 10 will be negative. Now, let's try this example yourself. Express the following numbers in standard form. A. 8,100,000. B. 51,200,000. C. 0.0000056. D. 0.0039. You can pause the video and try to solve it yourself. Here is the solution. For A, 8,100,000, the answer is 8.1 times 10 to the power of 6. B, 51,200,000, the answer is 5.12 times 10 to the power of 7. C, 0.0000056. The answer is 5.6 times 10 to the power of negative 6. D. 0.0039. The answer is 3.9 times 10 to the power of negative 3. Do you get the answer correctly? Expanded notation. In this section, we reverse the process where the standard form is given, we change it into the normal regular numbers. Let's look at this example. Write the expanded notation of each of the following numbers. A. 6.12 times 10 to the power 7. B. 8.745 times 10 to the power 9. C. 4.38 times 10 to the power negative 5. And D. 2.412 times 10 to the power negative 4. Here is the solution. As mentioned just now, the process is reverse. Here, this is the number in standard form, 6.12 times 10 to the power 7. First step is we check the power of the 10. So for this case is 7, we need to move the decimal point to the right for 7 times. So let's count. This is the decimal point and move to the right. 1, 2, 3, 4, 5, 6, 7. So in other words, they are 5 zeros behind. So it is 61,200,000. For B, 8.745 times 10 to the power of 9. So the power of 10 is 9, hence we need to move the decimal point 9 times to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Hence the answer is 8,745,000,000. C. 4.38 times 10 to the power of negative 5. So now the power of 10 is negative 5. We need to move the decimal point to the left for 5 times. So 1, 2, 3, 4, 5. Hence the answer is 0.0000438. D. 2.412 times 10 to the power of negative 4. And we need to move the decimal point 4 times to the left, as the power of 10 is negative 4. Hence 1, 2, 3, 4, and the answer is 0.0002412. Now let's try this similar example yourself. Write the expanded notation of each of the following numbers. A. 3.8 times 10 to the power 6. B. 5.871 times 10 to the power 12. C. 1.365 times 10 to the power negative 6. D. 2.46 times 10 to the power negative 7. You can pause the video and try to solve it yourself. Alright, here's the solution. For A, 3.8 times 10 to the power 6. The answer is 3,800,000. For B, 5.871 times 10 to the power 12. The answer is 5,875 billion. C. 1.365 times 10 to the power negative 6. The answer is 0.0000001,365. D. 2.46 times 10 to the power negative 7. The answer is 0.000000246. Do you get the answer correct? Now, let's learn the 4 operations of standard form. Here is an example. Without using a calculator, calculate the following. A. 8.745 times 10 to the power 9 plus 6.12 times 10 to the power 7. B. 8.745 times 10 to the power 9 minus 6.12 times 10 to the power of 7. C. 8.745 times 10 to the power of 9 times 6.12 times 10 to the power of 7. D. 8.745 times 10 to the power of 9 divided by 6.12 times 10 to the power of 7. Here is the solution. For A, 8.745 times 10 to the power of 9 plus 6.12 times 10 to the power of 7. So firstly, we need to check the power of 10. So they are not the same. We need to make the power of 10 to be the same. So we choose the larger power as the standard power. So for this case, it is 8.745 times 10 to the power of 9 plus 0.0612 times 10 to the power of 9. The next step is we can actually factorize out the 10 to the power of 9 outside, and inside the bracket it is 8.745 plus 0.0612, and the answer is 8.8062 times 10 to the power of 9. Similarly, for the operation of subtraction, B, 8.745 times 10 to the power of 9 minus 6.12 times 10 to the power of 7. So again, we need to make sure that the power of 10 is the same. So for this case, we change the 10 to the power of 7 to 10 to the power of 9, and we get 8.745 times 10 to the power of 9 minus 0.0612 times 10 to the power of 9. And similarly, we can factorize the 10 to the power of 9 outside the bracket, and inside the bracket we get 8.745 minus 0.0612, and the answer is 8.6838 times 10 to the power of 9. C. 8.745 times 10 to the power of 9 times 6.12 times 10 to the power of 7. So now it is the operation of multiplication. We don't have to standardize the power of 10. So what we can do is the number multiplied with the number, and for the 10, we can just group them in another brackets. So we can do as usual. For 8.745 times 6.12, we get 53.5194, and for the multiplication of 10, since they have the same base, we can add the power. So it is times 10 to the power of 9 plus 7. And the answer is 53.5194 times 10 to the power of 16. And since the number is not between 1 to 10, we can lower down and put it in standard form, which is 5.35194 times 10 to the power of 17. Similar for D, 8.745 times 10 to the power of 9 divided by 6.12 times 10 to the power of 7. So for division, we can rewrite it as a fraction. 8.745 times 10 to the power of 9 divided by 6.12 times 10 to the power of 7. So number divided with the number, the power of 10, we can just do the operation of minus since it is a division. So 8.745 divided by 6.12, we get 1.428. And 10 to the power of 9 minus 7, we get 10 squared. So, and the answer is already in standard form, so we don't have to do anything here. Here is one example that you can try yourself. Without using a calculator, calculate the following. A. 1.365 times 10 to the power of negative 6 plus 2.46 times 10 to the power of negative 7. B. 1.365 times 10 to the power of negative 6 minus 2.46 times 10 to the power of negative 7. C. 1.365 times 10 to the power of negative 6 times 2.46 times 10 to the power of negative 7. D. 1.365 times 10 to the power of negative 6 divided by 2.46 times 10 to the power of negative 7. You can pause the video and try to solve it yourself. Alright, here's the solution. A 1.365 times 10 to the power of negative 6 plus 2.46 times 10 to the power of negative 7. We need to standardize the power of 10, and we will choose the larger power, which is negative 6. Therefore, for this case, it is 1.365 times 10 to the power of negative 6 plus 0.246 times 10 to the power of negative 6. So the number add together, and we can bring out the 10. So it is 1.365 plus 0.246 times 10 to the power of negative 6, and the answer is 1.611 times 10 to the power of negative 6. For B, 1.365 times 10 to the power of negative 6 minus 2.46 times 10 to the power of negative 7. Again, we need to standardize the power of 10, so we choose the larger power. Therefore, it is 1.365 times 10 to the power of negative 6 minus 0.246 times 10 to the power of negative 6. We can factorize the 10, and we just minus a number 1.365 minus 0.246, and outside the bracket times 10 to the power of negative 6, we get 1.119 times 10 to the power of negative 6. For C, 1.365 times 10 to the power of negative 6 multiply with 2.46 times 10 to the power of negative 7. So the number can multiply with the number, the 10 multiply with the 10. So 1.365 times 2.46, we get 3.3579, and 10 negative 6 times 10 negative 7, it is 10 to the power of negative 6 plus negative 7, we get 3.3579 times 10 to the power of negative 13. And we can leave the answer in 3 significant figure, which is 3.36 times 10 to the power of negative 13. For D, 1.365 times 10 to the power of negative 6 divided by 2.46 times 10 to the power of negative 7. So we can write it in fraction form, which is 1.365 times 10 to the power of negative 6 over 2.46 times 10 to the power of negative 7. So the number divided with the number, and for the power of 10, we can do a subtraction here. So 1.365 divided by 2.46 times 10 to the power of negative 6 minus negative 7, which will give us 0.5549 times 10 to the power of 1, and the answer is 5.55 in 3 significant figures. Do you get the answer correctly? Prefixes. What are prefixes? Prefixes are also used to represent very large and very small numbers. They are used in everyday life situations as they are more easily read and understood. So, here are a list of prefixes, and I'm going to show you how to remember prefixes easily. So I draw a red line here so that it will represent the big numbers and the small numbers. So we start with kilo. The symbol is K. It means it is 1000. So it is value of times 10 to the power of 3. Mega, symbol is M. The meaning is million, and the value is multiplied with 10 to the power of 6. The next prefix is giga. The symbol is G. It means billion. The value is times 10 to the power of 9. Next, tera. The symbol is T. The meaning is trillion, and the value is times 10 to the power of 12. There are more prefixes for the representing the big number, but at our level, it is enough to reach at tera. So all these represent big numbers. How about small numbers? So we start with deci. The symbol is small letter d, and it means tenth. The value is times 10 to the power of negative 1. Next, centi. The symbol is C, and the meaning is hundred. The value is times 10 to the power of negative 2. The next is million, milli, and the symbol is M. It means thousands. The value is times 10 to the power of negative 3. The next level is micro. The symbol is mil, and the meaning is millionth. So the value is times 10 to the power negative 6. Next, nano, symbol is small letter n. The meaning is billionth, and it is times 10 to the power negative 9. Next, pico, symbol is small letter p. The meaning is trillionth, and the value is times 10 to the power negative 12. And these values represent small numbers. Now, let's see one example related to prefixes. Without using a calculator, calculate the following. A. 2.38 kg plus 520 g. B. $3.28 billion minus $614 million. C. 15.24 megameters times 250 kilometers. D. 38.7 terabyte divided by 3.6 kiloseconds. Here is the solution. For A, 2.38 kg plus 520 g. So, similar with the previous example, we need to standardize the unit. So, we usually choose the larger unit, which is, for this case, is kilogram. So, it will be 2.38 kilograms plus 520 divided by 1000 kilograms. As the gram changed to kilogram, we need to divide the value by 1000. So which will give us 2.38 kg plus 0.52 kg, and the answer is 2.90 kg. For B, $3.28 billion minus $640 million. Again, we need to standardize the unit. So we change the million to billion, which we need to divide the value by 1000, as 1 million is 1000 times smaller than 1 billion. Therefore, it will be $3.28 billion minus 640 over 1000 billion dollars, which is $3.28 billion minus $0.64 billion, and the answer is $2.64 billion. For C, 15.24 megameters times 250 kilometers. So we have to change the prefix into standard form. So 15.24 megameters becomes 15.24 times 10 to the power 6 meters. So 250 kilometers, it is 250 times 10 cube meters. So after that, meters multiplied with meters, we get meter square. It will be 15.24 times 250 times 10 to the power 6 times 10 to the power 3. So the answer will be 3810 times 10 to the power 9 meters square. But the 3810 is not in the range of 1 to 10. So I have to put it into the standard form, and the answer will be 3.810 times 10 to the power 12 meters square. Or it is 3.810 terameter square. For D, 38.7 terabytes divided by 3.6 kiloseconds. So we can change it into fraction, which is 38.7 times 10 to the power 12 bytes over 3.6 times 10 cube seconds. After that, the number divided by the number 38.7 over 3.6 and the 10. So we can just power we minus them as it is a division. So it is times 10 to the power of 12 minus 3. So 38.7 over 3.6, we get 10.75, and multiply with 10 to the power of 9 bytes per second, which is 10.75 gigabyte per second. Now you can try this similar example yourself. Without using a calculator, calculate the following. A. 5.26 milligrams plus 465 micrograms. B. 35.8 nanoseconds minus 46.7 picoseconds. C. 90 megameters per second times 250 milliseconds. D. 189.6 millimeters divided by 52 kiloseconds. You can pause the video and try to solve it yourself. Alright, here's a solution. For A, 5.26 milligrams plus 465 micrograms, we need to standardize the unit. So for this case, we will change to milligrams. Therefore, it is equals 5.26 milligrams plus 465 over 1000 milligrams. And it is 5.26 milligrams plus 0.465 milligrams. We get 5.725 milligrams. For B, 35.8 nanoseconds minus 46.7 picoseconds. We also need to standardize the unit. So we will change it to nanoseconds for this case. So it will be 35.8 nanoseconds minus 46.7 over 1000 nanoseconds. And we get 35.8 nanoseconds minus 0.0467 nanoseconds. The answer is 35.7533 nanoseconds. For C, 90 megameters per second times 250 milliseconds. So we change them into the standard form. So 90 times 10 to the power of 6 meters per second times 250 times 10 to the power of negative 3 seconds. Okay, now the number multiplied with the number, the 10 multiplied with the 10, and the unit multiplied with the unit, which gives us 90 times 250 times 10 to the power of 6 times 10 to the power of negative 3 meter per second times seconds. Okay, so 90 times 250, we get 22,500. For the 10, if we times 10 to the power of 6 plus negative 3, and for the unit, it is meters. Right, we get 22,500 times 10 to the power of 3 meters, or 22.5 times 10 to the power of 6 meters, or it is equals 22.5 megameters. For D, 189.6 millimeters divided by 52 kiloseconds. So we have to change it into standard form and put it in fraction, which gives us 189.6 times 10 to the power of negative 3 meters over 52 times 10 to the power of 3 seconds. So the number divided by the number, for the power of 10, we do the subtraction. So it is 189.6 over 52 times 10 to the power of negative 3 minus 3 meters per seconds. We get 3.6462 times 10 to the power of negative 6 meters per seconds. We can also leave it. The answer is 3.65 micrometers per seconds in 3 significant figures. Now, let's look at word problems related to standard form. Here is an example. The following data gives the population estimates of certain countries in the year 2021. Here is the data. For USA, the population is 3.32 times 10 to the power 8. India is 1.39 times 10 to the power 9. The population of China is 1.44 times 10 to the power 9. And Malaysia, the population is 3.28 times 10 to the power 7. A. Express the population of China in billion. B. Determine the difference in population between USA and India. C. Determine the ratio of population of Malaysia to that of USA. Express your answer in the form of 1 to n. Here is the solution. For A, the population of China is given 1.44 times 10 to the power of 9, which is 1.44 billion. For B, the difference is we take the bigger number minus the smallest number, which is 1.39 times 10 to the power of 9 minus 3.32 times 10 to the power of 8. So again, we want to standardize the power of 10. So it becomes 1.39 times 10 to the power of 9 minus 0.332 times 10 to the power of 9, which gives us 1.08058 times 10 to the power of 9. C, the ratio is 3.28 times 10 to the power of 7 to 3.32 times 10 to the power of 8. Okay, since we want to make the ratio to be 1 to n, so both numbers will have to divide by 3.28 times 10 to the power of 7. And the answer is roughly 1 to 10. Alright, now let's try this similar example yourself. Given that x equals 9.6 times 10 to the power of negative 16 and y equals 1.2 times 10 to the power of negative 8. Evaluate the following, leaving your answers in standard form. A, 2x minus y squared. B, x over y times 10 to the power of negative 5. You can pause the video and try to solve it yourself. Here is the solution. For A, 2x minus y squared, just substitute the value and we get 2 times 9.6 times 10 to the power of negative 16 minus bracket 1.2 times 10 to the power of negative 8 square. So after that, we can remove the bracket for the first term, where we get 2 times 9.6 times 10 to the power of negative 16 minus for the second term, we can split the numbers out and we get 1.2 square times 10 to the power of negative 8 square. After that, for the first term, just times 2 times 9.6, we get 19.2, then times 10 to the power of negative 16, and for the second term, 1.2 square, we get 1.44, and for 10 to the power of negative 8 square, so we just multiply the power, we get 10 to the power of negative 16. And these two terms, they have the same power of 10, then we can just subtract 19.2 minus 1.44, we get 17.76, then times 10 to the power of negative 16. And from here, we have to change it into standard form, and we get 1.776 times 10 to the power of negative 15. For B, x over y times 10 to the power of negative 5, just substitute the values, we get 9.6 times 10 to the power of negative 16 over 1.2 times 10 to the power of negative 8 times 10 to the power of negative 5. So number divide with the number, and for the power of 10, so the top power minus the bottom power. So we get 9.6 over 1.2 times 10 to the power of negative 16 minus, in bracket, negative 8 plus negative 5. We get 8 times 10 to the power of negative 3. Now let's look at the words problem related to prefixes. Here's an example. The distance from the Earth to the Sun is 149.5 gigameters. The distance from Mercury to the Sun is 4.5 times 10 to the power of 4 megameters. A. Find the ratio of the shorter distance to the longer distance. Give your answer in the simplest form. B. Find the distance from Earth to Mercury given that the Earth, the Sun, the Mercury are in a straight line and the Sun is between the two planets. Here is the solution. For A, we have to compare and determine which distance is the shorter distance and which distance is the longer distance. So 149.5 gigameters equals 149.5 times 10 to the power of 9 meters. And change it into standard form, we get 1.495 times 10 to the power of 11 meters. For 4.5 times 10 to the power 4 megameters, it is equals to 4.5 times 10 to the power 4 times 10 to the power 6 meters. Combine them together, we get 4.5 times 10 to the power 10 meters. Therefore, the first distance is the longer distance, and the second distance is the shorter distance. Therefore, to form the ratio, shorter distance over longer distance equals 4.5 times 10 to the power 10 meters over 1.495 times 10 to the power 11 meters. So the number divided by the number, and for the power of 10, we do the subtraction. So 4.5 over 1.495 times 10 to the power of 10 minus 11. We get 90 over 299. For B, so we just need to add the distance together since they are in a straight line. So 1.495 times 10 to the power 11 plus 4.5 times 10 to the power 10. Okay, before we want to do the addition, we have to standardize the power of 10. For this case, we choose 10 to the power 11. So it is 1.495 times 10 to the power 11 plus 0.45 times 10 to the power 11. So we can add the number together, 1.495 plus 0.45 times 10 to the power 11. And the answer is 1.945 times 10 to the power 11 meters. Okay, we can change it to 194.5 times 10 to the power 9 meters, which is 194.5 gigameters. Now you can try this similar example yourself. The size of a hydrogen atom in the shape of a sphere is 70 picometers. Express 70 picometers in meters, giving your answer in standard form. And B, how many hydrogen atoms must be placed in a straight line to make a length of 35 centimeters? Give your answer in standard form. You can pause the video and try to solve it yourself. Alright, here is the solution. For A, 70 picometers equals 70 times 10 to the power negative 12 meters, and change to standard form, it is 7.0 times 10 to the power negative 11 meters. For B, 35 cm equals 35 times 10 to the power negative 2 meters, and the number of hydrogen atoms to line in a straight line, we just take the distance divided by the diameter of the hydrogen atom. So 35 times 10 to the power negative 2 meters over 7.0 times 10 to the power negative 11 meters. So the number divided with the number, and the power of 10, for this case we minus because it is a division. So 35 over 7 times 10 to the power negative 2 minus negative 11. And we get 5 times 10 to the power 9 atoms. Alright, that's all for this video. Thanks for watching. Do you have any questions or thoughts to share? Feel free to write it down in the comment. I would love to hear from you. Do you like this video? Please don't forget to like it and share it with your friends. Until then, I will see you in the next video. Have a great day ahead.